Hi guys, how are you doing? I hope you're doing great. Welcome again to our today's lesson, and we are continuing with Euclidean Geometry. And today we are going to look at a theorem that says an angle at center is twice an angle at circumference. Let's try to understand what the theorem says. The terminology or the terms that are used in the question, there is an angle at center. So we need a center. And we need circumference. Of course, there is a circle, so there will be circumference. So let's draw our center here. The angle at center, what kind of an angle is it? It's an angle that is formed, okay? An angle that is formed by two radii. Radii is plural for radius. So the angle is formed by two radii. So I have a radius and a radius. They are forming an angle that's called the angle at center. The angle at circumference now is any angle that's going to be formed from the ends of the two radii that we have. From the end of this radius, if there is a line at circumference, remember at circumference, that's going to be formed, an angle that's going to be formed at circumference, remember at circumference, from the ends of these two radii, then it means that is the angle at circumference. An example is this one. There is one line, it goes up, then another line goes up. Now is angle at circumference, and we say this is the circumference of the circle. So make sure that the angle is really at circumference. So what the theorem is saying is this angle that you are seeing here and this angle, the relationship is that the angle here is twice this angle. Let's say this angle is x, this angle is y. We are saying y is equals to 2 times x. The reason being angle at center is twice 2 times angle at circumference, right? 2 times angle at circumference. This is the reason, and this is how we write it. Angle at center is equal to 2 times angle at circumference. Let's have an example. Let's say I'm given something like this. This is O, and I'm given radius, radius, and there are two lines from the ends of the radii, and then we are told that this is x, but this one is 60 degrees. What will be the value of x? For us to calculate the value of x, we know that x is equal to 2 times 60 degrees. In Euclidean geometry, we always need reasons. So you need to tell us the reason why. And the reason why we are saying this is 2 times that is because an angle at center is equals to 2 times angle at circumference, right? This statement, we shorten it that way, at circumference. Then we close and then we calculate. It means that x is equal to 120 degrees. Easy, right? Let's have another example. Let's say I have this and yes, this. And I'm told that this is 150 degrees. Can I find y? Of course, not a problem, because I would say that 120 degrees. This 150 degrees rather. 150 degrees. Which 150 degrees is this one? Is equal to 2 times y, right? This 150 is 2 times y. The reason is angle at center. Angle at center is equals to 2 times angle at circumference. So what do? We get 2y this side. It's equals to 150 degrees. Divide both sides by 2. Divide both sides by 2. Then it means that our y is equals to 75 degrees. So we can easily calculate when we know the theorems. You might be thinking like, why didn't we just say 150 degrees divided by 2 and then we get this one? You are right. We can do that as well. But here I was just writing what was consistent with our statement. So I was trying to make sure that we understand this statement. And when you just apply it the way it's supposed to be applied, you will not have any challenge. Sometimes we have a circle. Sorry, it's not really looking like a circle, but let's just assume it's one. And we have center O. Remember we said the angle at center is formed by radius and radius. So we do have radius here, we have radius here. They are forming the angle at center, and the angle is theta, let's say. But instead of going to meet there from the ends of the radius, they are not going there. They are going to meet here. Right? These two lines from the ends of the radius, they are not going to meet there. They are going to meet here. So this angle that is formed here, we call it the angle at circumference still. It's still the same theorem because we said the angle at circumference should come from the ends of the two radii that are forming the angle at center. So if this is 30 degrees, to find theta, I would really say theta is equals to 2 multiplied by 30 degrees. And what's the reason for that? Because angle at center is equal to 2 times angle at circumference. Yes, and then we continue. It means that here theta is going to be 60 degrees. Okay, let's look at another question. Let's say again, we have our circle here. Let me try better this time. Okay, this is our circle. And we are starting again from our two radii. There is a radius forming our angle at center. Remember, the angle at center is always formed by the two radii. Let's call that angle this time around beta. But instead of coming from here, meeting at the circumference there, or maybe coming and meeting somewhere here like the way they did, this time around, it's not going there. Let me change color for that. This line from here is going straight on top of this, going to the circumference. And here is starting at the end of the radius as required, but it's going to also meet this one here. So this one is now also the angle at center. Let's say this one is 50 degrees. We can easily calculate our beta. We say our beta is still equal to 2 times 50 degrees. So this is still the theorem that we're talking about here. It's still that same theorem, but it's only that instead of this line going there, it came right here on top of this line, right? But it's still the same thing. The reason for this is angle at center is equal to 2 times angle at circumference. And the answer is going to be equal to 100 degrees. Well, let's look at the last example. Sometimes you are given something like this. We have the sender, and instead of these two radii to go down the way these other ones are doing, because we don't restrict where they are supposed to go, they may actually go up here and up there. But they are still two radii, so they form an angle at center. Whether they form it that side or they form it this side doesn't matter, but the angle at center is formed by the two radii. So let's call this angle alpha. Then from the ends of the radius, remember, we are supposed to form an angle at circumference. So this angle at circumference is formed from the end of the two radii. This was O. And this is the angle at circumference. And let's say that angle is like 100 degrees. So how would we calculate alpha? In this case, our alpha is equal to 2 times 100 degrees. Again, what's the reason? The angle at center is equal to 2 times angle at circumference. Then what? It means that our alpha is equal to 200 degrees. So ladies and gentlemen, it doesn't matter for this theorem whether you are given this way, this way, this way, or you are given this way. It doesn't really matter. What matters is, do we have two radii to form the angle at center? The angle at circumference, is it formed from the ends of those two radii that you have just drawn? If you can see that those conditions are being satisfied, then this theorem can work. An angle at center is twice the angle at circumference. And we would say from all these statements, an angle at circumference is half angle at center, which means if I was given this one, I would divide by 2 to get that one. If I was given this one, I would divide by 2 to get that one. If I was given this one, I would also divide by 2 to get that one. So it's very important for us to know this theorem that way. I hope it was understandable. Please try to understand this theorem in all the cases that we have given you. Have a great day.